Good morning, good afternoon, and good evening. Welcome to today's webinar. My name is Genevieve Cross, and I am your host today for today's, and also I am formerly known as Miss Scarlett too, from Clue. Before we get started, I just want to go over a few housekeeping items. The session is being recorded, and the on-demand version will be available shortly after we finish, and we will be sure to send it to everyone who is attending today's event. So you can share it with your own team, or if you want to watch it again. If you have any questions during this broadcast, you can submit them in the Q&A section, which is on the right side of your screen. And we will answer them as we can, like during the actual broadcast itself, or we'll reserve them for the end for the actual Q&A session. In the handout panel, you'll find two handouts. One is an ebook, which is on the 5 obstacles of Kubernetes challenges. And the second one is actually a PDF of the presentation that we're showing today. And for today's webinar, we're diving into the mysterious world of Kubernetes with our interactive Kubernetes challenge workshop. You're joining us to solve some complex application mysteries in real time with StackState, which is now a part of SUSE as the Rancher observability solution. Today with me, we have 2 guides. I have Andreas Prins, who is the VP of Observability. And I also have Jeroen van Erp, who is our technology evangelist. Andreas is Colonel Mustard, and Jeroen is the Professor Plum. And to kick this adventure off, Andreas, I'm passing it over to you.
Excellent. Thank you so much, Miss Scarlett. Always a pleasure working with you. And where we will start is, let's go to the overview of today. And really today what we would like to do is, before we get started, or actually before you get started, we just want to introduce the topic, because you might be new to Kubernetes observability. You might be a very big user of Rancher, but not so used to how to do very deep observability. And that's exactly what we will cover in a little bit of theory. Then, really important, Professor Plum will take over and give a brief introduction on StackState, on the capability that we will use today to do your observability. And then it's absolutely about time for you to get your hands on the keyboard, because we've prepared an environment where hopefully all of you at the same time can start searching for the solutions to solve the mysteries of Kubernetes observability. And before Jeroen takes over, let me guide you through 5 different slides that articulate the problems that we've seen at many of our customers. And the first one is a very, very common one, and that's the siloed telemetry web. Because imagine, if you need to solve a mystery, what would be amazing if all the hints line up towards the outcome, the weapon, the room, the person who did it. Well, and similarly, you can argue, if you have an outage, you would love to have your metrics, your events, your logs, and your traces lining up exactly to the outcome. If you pick a observability stack that consists out of distinct tools, it can be pretty hard to actually come to the clue and really understand what is going on in just seconds. But hey, we're here to solve mysteries. So that is one of the philosophies behind StackState, and what you will learn real quickly already in the demo from Jeroen, that by bringing the data together, correlating it, it becomes much easier to navigate and understand. That's the first part. The second one is all about dashboards. I do recall the days when I had to solve mysteries which were roughly similar 10, 15 years ago, when we were having all these dashboards on the wall in the office and everyone was looking at it until it turned red. A lot of metrics, a lot of line charts. The challenge there is that a line chart not always tells you what is the cause of the issue. There's much more needed. You need really a couple hints towards the clue, towards where to solve the mystery. And the challenge with dashboards, what we've seen, is they're often created by experts, but not necessarily useful for people who are lacking domain knowledge. So, do you know how to interpret all these dashboards that you would download from the internet in Grafana? Well, what we learned at all of our customers is that in particular this can cause issues. So what we thought at StackState is how can we not only collect the siloed data and bring them together, but how we can shape the dashboards in such a way that the most important information bubbles up real quickly, but secondly, that you can navigate from one resource type to the other without losing context. And again, in the demo, you'll see that. The third element is, imagine you have data, it's shaped up nicely in the dashboard. Do you have enough knowledge to actually understand what observability for your microservices application is? Do you understand if you deploy workloads to your clusters and you manage the clusters by Rancher, do you know how to build clarity on that entire stack? Well, if you think about solving mysteries, we do believe that bringing in the knowledge of observability, or if you like, operating reliable applications, is super important to put that into your observability solution. So rather than every time building the practice from team to team and educating everyone, how do you capture the knowledge of the best people you have who can solve these mysteries, put them in the solution, and then put the solution to work to help out all your engineers? And that is another element that we've added into our solution, StackState. We call it monitors. They do the heavy lifting and they contain the practice of observability. So if you would have this in place, the ultimate goal obviously is to reduce business impact. And the business impact is where we would like to talk about next, where Jeroen and I are still practicing our collaboration. So if you experience it's not going smooth, you know, fixing a couple murders or actually discovering who did what really requires teamwork. So we'll shine here today, Jeroen, no worries.
No, we always do. We always do. No problem.
Respect, my friend. All right, the business impact. Why, you would wonder, is observability so important? Well, the first thing, if you don't think about the observability practice or the rollout of the practice, I would say ultimately the biggest goal for any business is you put reliability at risk. And if you don't pay attention on how to roll that out, right, your platform engineers can become the bottleneck in solving issues because they need to jump into so many situations and they're actually not focused on optimizing the platform. So if you can capture that in your solution, you can free up time for them to maintain reliable applications. The other one, what we've noticed is that if you roll it out from team to team, and every team needs to create its own dashboards and define its own practices and set its own alerts, there's a ton of waste in the process. And we believe when bad things happen, also in the game, you need to solve it as quick as possible. And similar when it comes down to reliability issues. The other element, and I do recall back the days when I worked for ING, one of the bigger banks here in Europe, when there is an issue and you're all called together in the war room, most of the time your most senior engineers would go in there. And these are also the ones that have the highest velocity when it comes down to feature development. So also from that perspective, you should think through how to enable and empower many more people so my best engineers can focus on where they are good at, not necessarily troubleshooting. And last but not least, if you want to accelerate in the business, you need to think about autonomy for your engineering teams. And using a good observability tool can definitely help there. So now the question is, what does StackState bring to the Rancher portfolio? Well, StackState is what we call a full stack observability solution. And what that means is if you think about Rancher being able to manage, deploy all your clusters, and then the development teams and the product owners and everyone else starting to deploy applications onto that cluster, you want to know and learn what is running and how is the health of these elements, how are they interacting with each other. And that's what we do with StackState. So the platform engineer can get a much better understanding of the workloads running on their application. And at the same time, and this is really important, if you're coming more from a business perspective and you don't care too much about the underlying infrastructure, still StackState connect the dots, and you can easily navigate from a high-level service all the way deep down towards a cluster, a namespace, a pod, a container, or even a process that is running there. And that is important because often the issue that we see or we think we see is not necessarily the cause. So being able to relate cause and effect is really important when it comes down to the game, to Clue, but it's also important when it comes down to observability. And that's exactly what we would like to do. So how do we do that uniquely with Rancher Observability? Well, we believe in 4 main principles. The first principle is make the data accessible in a secure fashion without giving everyone access to production clusters and whatever command line tools. Second, if you've made this data available, really important is to start correlating, connecting, and providing a ton of dashboards out of the box that are connected, that you can easily go from one to the other without losing context. So then you have the data, and then it's all about the practice itself, detecting in a very easy fashion all the basic observability issues that could go wrong, or reliability issues. Because if you do that, well, then solving it goes quickly. And last but not least, really important, are the remediation guides. We provide guidance step by step, and you will experience that in the workshop yourself, step-by-step guidance to go to the cause of the issue. And these 4 ingredients will absolutely help you to reduce your MTTR, mean time to repair, and therefore increase the reliability of your business. Let's have a look.
Thank you. So welcome. I'll quickly jump out of the slide and dive into stack state. So you see here basically a landing page of stack state, which is in this case the pods overview page. So for all of the different Kubernetes resources, and we show them here in the menu on the left hand side, there are these overview pages which show you basically what all is running in that cluster. And in this case, it's filtered down by the namespace. So I've already pre-filtered it down so that we're not overwhelmed. And you can also easily filter this down per cluster. So I can actually look at a specific cluster and a specific namespace to see what's running there. Now this overview looks great, right? We see some colors, we see some mini charts there, but where stack state really shines is when we switch this over into topology mode. And in our topology mode, what we show is not only what is running, but we show how is it connected. So what is talking to what? And my mustache is actually not really playing nice with me, but that doesn't matter. So yeah.
Are you telling me the mustache is fake?
It is definitely fake. It's so dark. It is definitely a fake mustache, but it looks good.
I wonder what else is fake on you. Let's park that conversation in the library later tonight.
Yes. So you know me. I will always go to the conservatory, not the library. I love my plants. So we see here a front-end pod, and what we see is where it is connected to. So we see it is connected to an ad service, it is connected to the checkout service, and we see also on this overview direct health information. So we see that in this case the front end is in a deviating health state, meaning in this case it's a front end, so it's user visible. Potentially users coming into this application, this is the OpenTelemetry demo application, so the Telescope web shop, they are actually seeing problems. So what do? We actually dive in. So we can click this component, and we could have also done that from the overview, but I really wanted to show you this topology. And we can dive into the component view. And now on this component view, you actually get a detailed overview of what is this component all doing and all of its observability signals. So we see it's about section, which actually shows you all the metadata coming from the cluster. It's a pod, it is in a running phase, it had 3 restarts, it had a specific IP running on a node, etc. And what we show is its status information coming from Kubernetes and its configuration information, so the full resource YAML. Why is it important? Because StackState actually keeps track of this over time, and it actually allows you to see what changed. So in this case, actually nothing changed for this component. There is actually another component which we'll show later on, which did change. But change is important because Andreas mentioned those signals. Change is actually the fifth signal that is important. We've got the metrics, the events, the logs, and the traces, but change is a whole observability signal on its own, because 9 out of 10 times, due to change, incidents happen. It's fact of life, right? If you don't change anything in the environment, it will keep on running as it should be, hopefully. Increase in traffic is, of course, also change. It's not only change of configuration, it's increase of traffic. As long as there's no change, nothing will happen typically. So on the right-hand side, or the central part of the screen, we actually, top of the screen, we see our monitors, the best practices that Andreas talked about. I'll dive into those in a moment. Below that, we see the events. So we categorize all of the events by specific categories. So we can actually see changes, and I'll show you a change here. So you can actually see what changed in this case for the front-end proxy. So it's restarted and got a new container ID in this case. Below the events, we see the logs. So StackState also collects all of the logs of the containers running. We can view them, we can grab through them, filter them down by severity. So we actually see that there are errors, right? I saw some red lines on our chart, and we can easily filter that down and analyze those further. And below the logs, we see our highlighted metrics. So these are not all of the metrics that StackState knows about. These are the metrics that StackState says are most important, or you have to look at them first, in this case for the pod. For a service, there are different metrics. So for a pod, we measure throttling, CPU usage, memory usage. Top of screen, we have a few other perspectives. So one of those is the metrics, where we show all of the metrics of this pod. And we show the fourth observability signal, the traces here. So you can actually also analyze your trace information here, clicking them, opening them, etc. You'll use these later on in our workshop also. So it's good to know where this is. But the monitors, I promise we dive into that. So let's do that. The monitor, in this case, the span error ratio monitor. We show a small description. Okay, what does it monitor actually? What does it do? Below that, a health timeline. So how did this evolve over time? And what you see is, you see a pattern, right? This is a demo scenario. So it's sometimes green, sometimes in the deviating state, so that there's always something to show. Below that, the monitor properties. So the health state, trigger time, and the evidence based on which this monitor triggered. So we see a metric here. The threshold for this metric is at 0.25%, is defined by the monitor, and you see it actually going over. And if you look closely on the top of, I have the health timeline still in view, you see that during the peaks, it's actually in an orange state. And last but not least, the infamous remediation guide. The secret ingredient that StackState offers to your development teams, to the application developers, that actually helps them troubleshoot the issue at hand. We list a number of possible causes in this case, and for each of those causes, we actually give you a deeper explanation. And what's important, and you'll use these again in our workshop, there are links, so you can easily navigate through StackState, because the remediation guide actually helps you troubleshoot as it should be. What happens when you click that link? You go to the specific page, in this case the traces. We get the error traces because the remediation guide said, well, analyze traces with an error status. But what you see is, I look to the right-hand side of the screen where this remediation guide is now in context. So you don't lose what you're doing, what you're troubleshooting during that troubleshooting journey that you're at. So there's no need to write this down. There's no need to take notes, screenshots of that remediation guide. It will be with you throughout that journey through your Kubernetes landscape.
Nice.
So
it's like a cheat sheet. If I have to win the game of Clue, I need to know something. I use this guide to guide me through the building, found the right room, the weapon.
Yeah, it will actually definitely help you in our journey, and we'll build that journey up with our workshop, right? The first exercise, the second exercise will be smaller than the last one, where you actually really have to use the remediation guide, navigate through a few different components, but we'll build that up, the journey. So I hope everyone actually at least has registered a number of things on how to go about stack state, how to travel through it. Let me quickly jump back into the slides again, and we'll start our troubleshooting workshop.
Ooh.
So, Colonel Mustard, do you want to do the honor?
Absolutely. So we're absolutely happy to have you all here to join us in the troubleshooting workshop. It's very, very simple. You just go to the link l.stackstate.com/challenges-2024. And while you're doing that, bear with me. We're going to do 5 challenges, and we practiced a little bit. We have more time than last time when we did it, so we certainly will get to the 5th one. And what we'll do is we start a challenge. Jeroen will navigate you towards the challenge. Then we'll bring up a polling question. You on your second screen or your primary screen start solving the issue. We probably make some really bad jokes, whatever, to fill up 1, 2, 3 minutes, a little bit depending. Then we close the poll, we look at the answers, and then Jeroen will guide you. Be aware, the answers are anonymous, so no worry if you give the wrong answer, absolutely not. But we really would like to challenge you to start doing the challenges with us, because that will give you a really good experience. In the back, I'm absolutely happy that you participate, because we're just doing one big performance test of stack state. So thanks for there. All jokes aside, let's go to l.stackstate.com/challenges-2024.
Yeah.
Let the challenge begin, and then Jeroen will flip to the first challenge.
Yeah, so, and if you land there, you should see this screen, right? I'm quickly showing it before diving into the challenges. This is where you should end up with. Yes, it's correct. All of these are in a bad state, and we'll handle 5 of them. The rest is up to the reader if after this workshop you want to have some fun and try the other 2. So, challenge number 1, it's Mrs. White's dilemma with the wrench. So we have that view that I just showed you. There's a pod there that's called Mrs. White's dilemma with the wrench. And there's a number of different options that you can choose from in the poll that Miss Scarlett will actually put up in a moment. It's either the container image does not exist, the pod cannot be scheduled, the pod fails its readiness probes, or there's an unyielding wrench attack. So somebody is really hitting it with a wrench.
Ooh.
So without further ado, go.
Poll.
Open up the poll, Miss Scarlett.
And then everyone can start in stack state actually working on solving this mystery. And I'll promise the first ones are really to warm up, and then it becomes a little bit more difficult with more imagination and more creativity. Isn't that what inspires us?
Yes, definitely. And I'm looking at the intermediate results in my window here, and I actually see some people choosing that there's an unyielding wrench attack. Ooh. That is interesting, right? I wonder who's hitting that Kubernetes cluster with a wrench.
That might be a really frustrated person.
Yeah, for sure, because you don't need a wrench to open a server, right? You need a screwdriver, everyone knows that.
Yeah. All right, the poll is already closed.
This was fast.
My proposal would be next time it stays open a little longer, because then people have more time.
Shall we first share the results? See what people chose. So I see that 21% of our viewers actually chose that the container image does not exist. 42%, the most, chose that the pod could not be scheduled. 27 chose pod readiness probe fails, and then a small 9% chose the unyielding wrench attack. So let's have a look at what the answer is. Need to switch back the screen. Yes, now we're in the right screen. So it was Mrs. White's dilemma with the wrench. So we click that pod, we end up in the pod highlight page. This is Mrs. White's dilemma. It is a pod that is very critical. It does not have any ready containers, no IP assigned, no node assigned yet. So what is the first thing we do? Colonel, you know the answer. We look at?
Obviously, the remediation guides.
The monitor. Yes, definitely.
Absolutely.
So we look at the pod ready state monitor, the one monitor that is red for this pod. And if we go top to bottom through this through the pod the monitor page, we actually see it has a red timeline. Okay, it's great, right? It was instantiated at 2 o'clock this afternoon, at least 2 o'clock in my time zone. In your time zone, that could be very well a different time.
Absolutely.
It's in a critical health state, and we actually see that this monitor has a reason attached. So for a number of monitors, actually, the reason field is immediately automatically filled. And it says that there are 0 out of 3 nodes available that can schedule this pod, because one node had an untolerated taint, 2 insufficient CPU, 2 insufficient memory. So there is a problem scheduling this pod. And then the remediation guide tells you what is the problem and how you can solve this. So in this case, indeed, the pod could not be scheduled. So the majority of the voters actually chose the right answer. I'm so glad. On to challenge number 2. Don't you agree?
Absolutely. Let's make it a bit more difficult.
Yes, so we're going on to Mr. Green's survival in the conservatory, my favorite place on the clue board. Well, we can choose that either this pod is being CPU throttled, the pod has had too many changes, it was expired by hitting it with a lead pipe. Well, that typically also expires people if you hit them hard enough with a lead pipe. And the pod has too much traffic coming into it. So, Miss Scarlett, the votes up, please. The poll. Thank you.
Excellent. So we go back to the same page. Either use the back button just next to the stack state logo, which will land you on the Start Cluedo 2024 challenge.
Or you can type the URL back in, right? There's
numerous ways to get there.
Yeah. I actually hadn't shown the back button. I missed that opportunity to actually show another cool feature, or smart history.
Exactly. Do you recall, Jeroen, playing Clue or Cluedo, how we would say it here in Europe, is that you could go from the billiard room to the launch, that there are secret gateways throughout the house?
I can't really remember. I have the kids version at home, and I played it actually with the kids. So that board is slightly simpler and actually doesn't have that. Probably they're now old enough to actually get the feel for the real game. All
right, some really good results coming in. A bit more unanimous than last time, which is really good. That means, or not, could be. But there's still a minute to go. More people are voting. That's really promising to see. More than 50% of the participants.
Yeah, I was just looking how much participants voted, right? It's 57%. So
that's amazing.
It's a good turnout, right? Hopefully we get over 60.
2 more. Come on. Yes, 60. Yes, there we go.
Nice, nice. So we really see an uptake in participation, right? That's good. And it's also a sign that people actually start to understand stacks. They start to know how they can navigate it. So I think
really good.
On my back, I did a good job there explaining it, right?
Absolutely. Absolutely. Let's close this one and take a look, Jeroen, at the results.
Yes. Show us the results, Miss Scarlett. Well, the overwhelming majority, 3/4 of the voters actually chose that this pod was being CPU throttled. And a mere 5% actually think it's being hit with the lead pipe. Well, let's have a look. If it's this obvious, right? That is should almost be the correct answer. Let's have a look. Oh, I didn't go back. So that's the right one. So we had the conservatory. So this pod is not in a critical state. So it's not critically bad, right? It's deviating. It has abnormal behavior. And what we see in our monitors is the first monitor actually being the CPU throttling monitor is triggered. Well, the answer was already so obvious in this case that I'm so glad most of you actually chose that, right? We see the evidence. We see that from 2 o'clock onwards, this pod is under heavy duress, right? The threshold for throttling is set at 90. It's way over that. It's at 98, 99% CPU throttling. What does the remediation guide tell you? Well, do the logical thing. Any Kubernetes expert would know this. You up the requests and the limits because this pod is actually suffering currently from a resource shortage. I think that really explains it.
What does it mean? What is the impact, Jeroen, of something like this on my business application?
What is the impact? Well, typically you'd see that any request being served from this pod is actually potentially waiting for a long time, right? And if we look at the other monitor, I can quickly show that that's our span duration monitor that shows, okay, for the traces, right? The incoming requests to this pod, how long are they taking on average? And we see that, well, if a request goes over 5 seconds, we trigger this monitor, and it does, right? Requests, HTTP requests coming into this pod actually take 10 seconds. So that's a long time on the web, right? People don't want to wait that long. This will cost us conversion if this was a web shop.
So we noticed, we know the cause of the issue in this case is the CPU throttling. The effect, right, is that the duration goes up for the request to be executed. So therefore, customers might be impacted. Excellent.
Yeah. Well, let's go quickly back to our clue challenges.
Yeah. So can you explain a little bit what you just did before because this is very interesting. Before we skip over it, there's a little arrow to navigate stack state real quick.
Yeah, definitely. Now, thank you for pointing that out to me because I do that so automatically after we introduced this last year. So we have our smart history here. Contrary to your browser button, this will not go back to every page, every link that you visited, but it will keep the most important stuff that you visited in stack state with you. So I visited this pod, I visited the clue challenges, I visited the pods overview clue challenges. So it will actually give you the list of things that you visited. And in this case, why do you see multiple of these? Because I visited multiple different times of this. So in this case, I just went back to that link and actually ended up here again where I wanted to be. So challenge number 3. Professor Plum. Oh, you have transparent secrets. Or actually,
yes.
Transparent secrets. So either my secret data is not secured, my certificate is self-signed, it's expired even, or I have an undisclosed secret weapon. I definitely do have that last, but I can assure you that's not the correct answer.
There are quite a bit of things undisclosed, Jeroen, I noticed lately with you. Absolutely.
Yeah, what did I not disclose to you?
Yeah, let's talk about that later tonight in the kitchen.
Yeah. We'll do that, my former CEO.
All right, let's go over to the challenge and bring up the poll.
Thanks. Yeah, we forgot that the poll is not open yet.
Yes, the votes are coming in faster than ever before.
Yes, because people already had time to do the troubleshooting before the poll was opened.
Exactly.
I'm curious to what they'll choose. Well, it could of course be that there's a hint in the title, right? Would it be so obvious? What you see, that's also interesting. Have you noticed, Colonel, that actually the votes are coming in faster and faster with each challenge?
Yes, absolutely.
So we're already at 60% within a minute after opening the poll. That's like, I would love it if this goes up to 75% in the 2 minutes that we regularly do, right? That's, that really feels that the audience is engaged with us and following along with us.
Absolutely.
So for all of you who haven't voted yet, do us a favor and try this. It's really fun to work with Rancher Observability Stack State, right? We keep on calling it Stack State because it has been the name for so long, but
Absolutely. All right, let's close the poll.
Can we get some results?
Surprise.
Wow, 90% security data is not secured. And then there are a few people think that either my certificates were self-signed or they were even expired. Oh, yes, so well, let's have a look. So we had the transparent secrets pod. Let's open it up. It's in a deviating state. It has one triggered monitor, which is the secret finding violation. So let's scroll down to what this says. Well, what you see here actually is that there is also a mini topology sometimes shown on the monitor page, right? If there's anything that it detects that is related, it will actually link them up and show them in the topology. So in this case, there are two components that have the same finding, the same monitor being triggered, and they are also related. So this pod is using, in this case, this config map, as we see here. And both of them are actually suffering from hard-coded secrets, which is, of course, a very bad thing to do, because if you hard-code your secrets in plain text in your pod configuration, I'm pretty sure that you don't want to do that because they're leaking, right? They're just out there in the open. In Kubernetes, you would at least use a secret, and sometimes you can actually also use an external vault to actually power those secrets, right, to fill them up. So we detected a specific secret using the secret detector that actually runs over all of the configuration that is being sent from your downstream cluster into stack state. And it triggers this monitor to show you that there is a problem going on and you will want to remediate this as soon as possible.
So can you show that also in the config file itself to show how simple it is to jump to the config file?
So I opened up and I was so fast that you probably didn't even notice. I closed the window. I clicked the configuration button to have a look at the configuration. And we see here indeed that there is a secret key here, or at least something that resembles a secret key in this case, because it's of course not a real secret key. I would not be so dumb as to use real secrets in this demo application.
Another question, Jeroen, that came into my mind, if you close this window, is can you so I do see at the top that you are in time travel mode. What does that mean? And what if you click go live? What's the distinction there?
Good question. Yes, we are in time travel mode. So as I said earlier during my demo, stack state can actually, it keeps track of, over time of all of your observability signals, of all of your changes. So what you can also do is go back in time. So in this case, I'm at a fixed point in time, roughly 20 minutes ago. I can go back even further to a state where this monitor wasn't triggered yet, because there was some lead time for the monitor before all of the data was being processed. So we see that it wasn't triggered yet, but 15 minutes after this pod came online, actually it had triggered the secret finding violation. And we can travel over time. So you can also do post-mortems. If the issue was resolved, we can actually jump back in time and do a post-mortem over this data, see how everything was built up. So, and the cool thing is that stack state does not only keep those observability signals over time, but also your full topology. So even if pods go away, come back, other pods get instantiated instead of them. By traveling back in time, you'll see what was running when and basically how was the world looking at that point in time. And if I click back, go live, I'm actually at the current point in time, and you see that the time is now live. It started running again.
Amazing. There are quite a bit of questions coming in, by the way. I noticed, Sam, Lei, thanks for asking. We'll come back to it at the end. There's one very specific question, Jeroen, from Rajesh, and he's asking, how does it find this secret? Is it checking for any key value, regex? Can you elaborate a little bit on that?
I can actually. It's using a secret scanner. So we are actually using a generic scanner that just scans through the entire file and looks for high entropy strings. So basically, a high entropy string is anything that was semi-randomly generated and typically has a specific prefix. So in this case, it's an OpenAI API key prefix and length that it uses. So it does both, right? It has a number of specific things that it checks for and high entropy strings.
Excellent. So StackState already has the data, right? We have the files, and then we add some additional scanning or whatever libraries on top to find these type of things.
Yes.
Excellent. All right, thanks a lot. And I hope that answers the question. Let's go to the next one. We still have 2 to go, and we're perfectly on time, although these ones slowly a bit.
Yeah, this one is still pretty good. So we've got Mrs. Peacock and the Abandoned Vault. And there's something special because in this case, you won't be looking at a pod as far as I remember, because possible answers for these are, it is victim of persistent dagger slashing, the persistent volume is nearing its capacity, it's no longer attached, or it lost its data integrity flag. Well, Miss Scarlett?
There we go.
Yes, I see a poll coming up. And the votes are coming in the first half minute. Over 35% of people already voted. This must be a new record.
Or the remediation guide helps tremendously in coming to the right conclusion.
Yeah.
And that's really where we are aiming for. Eh? So you could argue, hey, is it so simple? But that is our mission. Our mission is indeed to make coming to the conclusion of what happened when, where, so easy. Because if you do so, you can fix it, you can resolve it more strictly, and then move back to your regular real work, adding new features, improving performance, or reducing cost, reducing footprint, you name it. So yes, right? It is demonstrating that solving issues, even without you being an expert, can be so simple. And I propose we close the poll and we go back to the answers.
Yes. Oh, show us the answers, the votes. Well, some people actually think that we were stabbing this persistent volume with the dagger, but the majority actually considered the persistent volume is no longer attached to a pod. Let's have a look. I forgot to go back after our previous session, so let's do that. And we actually have the abandoned vault. As you see, in this case, it is a persistent volume claim that we're visiting. The highlights page for a persistent volume claim looks different, right? It's not a pod, so it doesn't have all of the pod statistics. It specifically also doesn't have logs attached to it. In this case, there's no disk space usage information. And our monitor is actually saying, well, this persistent volume is orphaned, so it is no longer attached to a pod. Why is this important? Because this typically can pose security and compliance risks, meaning there's a persistent volume still there, because the claim is still there, but there's no longer a pod actually attached to that claim. So all of the data belonging to that pod is actually still living inside of that cluster. And if there's secret data in there, stuff you don't want or don't need anymore, this is a security and compliance risk.
And how does StackState know? How are we able to detect that
Yes, good question, because in this case, there is no metric. Typical observability tools can monitor on metrics, right? Look at your Grafana, look at a number of other tools. they monitor metrics. In this case, StackState actually uses StackState's biggest strength, right? The topology to determine, is the world still connected as it should be? So this is a monitor that's based on topology.
Nice. So it checks for PVCs or persistent volumes if they are actually still attached.
Yes, and if we look at our topology, and I'll quickly expand that, and I hadn't shown you that before, so you can actually also expand your topology. So if you're looking at a specific piece of the world, you can actually add in different other pieces of that world that are connected to it. And you see that in this case, the persistent volume claim still has a persistent volume attached to it, but there's no pods attached to it anymore. So it's unclaimed, it's orphaned at this point in time.
Excellent. So then there's a question from Harshiman. I can answer that is, we can lose critical data if we delete a persistent volume. And that's absolutely true. And that's why the system itself, StackState, doesn't delete it automatically. It warns you, it detects it, and then it's up to you, the human, to still assess indeed if it can be removed. But most likely the answer is a yes, and you will save a little bit of cost there as well. Going back a little bit, but also it's applicable to every monitor. Sergey is asking a question, Jeroen, how long does it take for that the monitor finds the violation from the previous one, and how often does it recheck? Can you explain how you configure that interval?
Yes, so the interval slightly depends. Hopefully, can we show that on the playground? Because we can't add monitors on our playground. So these are all the monitors that StackState actually knows about. And if I can't edit them here. I would need to switch to a different environment actually to show you the details. But for every monitor, you can configure basically a check interval. Check every, it's actually seen here, right? It's
yeah.
Luckily we show it. So some of these monitors are set for 30-second intervals. The CPU throttling checks every 60 seconds. Certificate expiration only every hour. So there's a number of different intervals that you can configure just per monitor on how often it checks.
Yeah, excellent. All right, and then the first time what we've seen is it often takes the first 30 seconds before it kicks in, because it's scheduled, so it sometimes takes a minute before the first time that it will fire up. All right, let's go quickly to the last challenge, because there's still a couple other questions I would love to answer. So let's take another 3 minutes and then we do a little bit of Q&A.
Yeah, I went back already, and let's do the slideshow. This one is slightly more complex. It's called Kernel Mustard, being you, and the sluggish server. So option 1 is this pod has a slow dependency. Option 2, it is being terminated by a revolver. Option C is it has a memory leak. Or D, there are too many calls to different services. Well, this is the last challenge. So we've actually also put you up for a challenge. This is where you'll really use the remediation guide to start your troubleshooting journey.
All right,
Miss Scarlett?
We get some feedback. Great session so far. Thanks for the great demo, guys. And Daniel and Christopher will come back to your questions in a minute as well. Juan Carlos, thank you so much. Nice product. I'll take that as a compliment.
I'll definitely take that as a compliment.
Well, I'll probably just answer a few questions in the meantime. Daniel asked, I'd like to ask how StackState Server works in an on-prem infrastructure. Is there any feature that is not available? The answer is no. It works. It works in SaaS, on-prem, self-hosted, or even air-gapped. There's feature parity amongst all these different deployment models. Why? Because we believe that cloud-native way of thinking and troubleshooting should be brought independent, whether or not you're in a public cloud, whether or not you're in your self-hosted cloud, or what else. So that is the reason.
We don't differentiate between which hyperscaler you're running, or whether you're just running on-premise in your own private data center.
Then the question from Todd, I can answer that as well, although official publication will come soon. Is this work in standard Rancher, not just Prime? The rich feature set that we're experiencing today will be Rancher Prime. There will be a slightly smaller subset, but still full monitors and all these type of things that will come also over time towards the community. So stay tuned for exact details. The acquisition is only 4 or 5 weeks ago, so we're still working on that. Juan is mentioning that this challenge might have two answers. Well, Jeroen will come back to that in a bit. Absolutely.
Yes, it could be that you're slightly tempted to choose another answer, but I think in the end there's only one real answer for this one.
One more question for you, Jeroen, and then we go to do it together. Chris is asking, does TechState leverage Prometheus as its collector?
The collector of metrics, we actually have a Prometheus compatible intake. So if you have any Prometheus based exporter, you can actually point that into the TechState Prometheus remote write endpoint, which allows TechState to actually also collect your custom metrics. TechState itself does not depend on Prometheus or Grafana for its data collection.
All right, let's bring up the results.
So, slightly more varied than the previous few challenges. So the majority actually chose that the pod had a slow dependency. Close second is it has a memory leak. And third is too many calls to different services. What do you say? Let's have a look, right?
Yes.
It was kernel mustard and the sluggish server. So we see this pod being in a critical state, and it has two monitors being triggered. It has HTTP response times that are above 3 seconds, and it has a long span duration. And now, for demo's sake, I'll choose the span duration because that remediation guide is slightly more extensive. And we see indeed the triggered evidence, right? The metric and our remediation guide. So if we look at our possible causes, it is a slow dependency, it had a recent update, the load increased, memory leaks, or environmental issues. So if we analyze the traces, we actually can click on the trace perspective link. Showed you that earlier in the demo, and this actually brings us to the trace perspective, gets the remediation guide in context, and we can expand this trace. And now something broke in the demo or in the workshop. Ooh, let's have a look again. What did I do wrong? Well, I can guess what's going wrong. There it is. So we actually see the expanded trace, right? It's what the remediation guide says, and I should actually read the remediation guide instead of doing this by head, because I've done this so often that I don't read anymore. So expanding a trace will show its full trace with any error statuses and or slow services. So if we look at the length of the span, it's over 5 seconds, right? And a big portion of time is actually caused by another component. So these spans are color coded. So topmost span is always the green one. That's my span. And any other components I'm calling out to, right? This is a distributed trace. It goes over different components in this cluster, in this application. So it actually calls out to a different component, in this case, Mr. Green in the conservatory. And remember our, I think, second challenge. We know that Mr. Green was actually being CPU throttled, so it was being slow. So in this case, we actually had a slow dependency. Mr. Green was in trouble, was slow to respond, which actually led us to also become slow because we depended on the response from Mr. Green. So kudos to everyone that actually answered option A, right? The pod had a slow dependency.
Amazing.
You could have said that there were too many calls to different services. That it's half right? It's.
I'm very curious, conscious of time. Can you go once back to the Cluedo overview view? Because the webinar is about to end in a few minutes. A couple more very important remarks. Lock yourself out. There are many more that you can do here. There's a lot more that you can try out in the online playground. No need to install anything. It will be publicly available. And with that, let's go to the last slide, because there are a few questions raised in the chat as well on when this will become available. My recommendation would be to follow this code. You need to fill in a little form, and then we'll reach out to you. Tech preview might be around the corner. We're looking for prime customers to shape it up together with us as a kind of a design partner. So absolutely happy to chat. There's a whole specialist sales team that has a lot of knowledge from TechState. that will help you out, do a trial, etc. So even before everything will be announced officially, we're looking for people to work with us. So please use this. And with having said that, I absolutely enjoyed your participation. And back to you, Miss Scarlett. You're still muted, I guess.
Yeah.
I hate when that happens. I just want to say thank you, everyone, for joining today's Kubernetes troubleshooting workshop. I hope you all were able to take away some knowledge on how you can actually, solve some of your own Kubernetes mysteries. With that, this session was recorded, and we will be sharing this recording with all attendees. So you can take a look at it again, or you can also share it with your own team. So have a great day.
Thank you so much.
Bye-bye.